This video is on blood, part 3. Last time we were talking about the production of erythrocytes, which is called erythropoiesis. The production of leukocytes is called leukopoiesis. Just as erythropoiesis is controlled by hormones, so is leukopoiesis. It's controlled by a family of hormones, two families actually, called cytokines. Cytokines are chemicals that influence cell development and differentiation. By differentiate, I mean it helps cells become more specifically the type of cell that they're going to be. So they might go from a stem cell to becoming a basophil, or a stem cell to becoming a lymphocyte. Cytokines are interesting, and right now in our current period of COVID-19, some of the adverse effects of the COVID virus appear to be due to what's called a cytokine storm. And this results in the release of many cytokines, which cause a huge, almost complete body inflammatory response. However, cytokines are a normal part of your body, and they include two groups or two families: interleukins, which are chemical messengers. We'll talk about these in the immune system a little bit more. And there are many interleukins. They are actually labeled IL-1, IL-2, and so on. And then something called colony stimulating factors, or CSF. So let's talk about colony stimulating factors, which are hormones which regulate white blood cells. The first type of colony stimulating hormone is called MCSF. So what type of blood cell, white blood cell, do you know of that begins with the letter M? If you said monocyte, you would be correct. So MCSF stimulates production of monocytes. Another type of colony stimulating hormone is GCSF, and G stands for granulocytes. So this stimulates the production of granulocytes. And remember that these include white blood cells that have granules in their cytoplasm, such as neutrophils, basophils, and eosinophils. GM-CSF stimulates production of both granulocytes and monocytes. And then there's another one, multi-CSF, which stimulates production of neutrophils, eosinophils, basophils, and platelets. Colony stimulating factors were discovered in the late 1970s, and they helped millions of people survive cancer. Often during cancer treatment, people are exposed to harmful chemotherapy and also radiation therapy, which often destroys the bone marrow. Remember, the bone marrow is where the stem cell is from which all blood cells form. So once we were able to produce these different types of colony stimulating factors, physicians were able to give this to patients who had a radically damaged bone marrow and promote the production of different types of white blood cells. So cytokines are a very important family of chemicals, and the most important source of cytokines are macrophages and T cells. However, the regulation of cytokines is not completely understood, and B lymphocytes and T lymphocyte cell production is still mainly regulated by exposures to antigens. So in other words, T and B cells are stimulated to be produced once they're exposed to the foreign agent. This picture is showing the production of white blood cells, or leukopoiesis, and what I'd like you to take away from this is actually where the different hormones come into play and kind of nudge the cell towards a different pathway. So we're starting here in the bone, and what kind of bone do you think this is? What bone actually is this? So if you said the femur, that's what it is. And in the femur, in the epiphysis, there's a good amount of red marrow. In the red marrow, you will find the hemocytoblast. Remember, that is the stem cell. And hemocytoblasts can differentiate into either a myeloid stem cell or a lymphoid stem cell. Now, lymphoid stem cells are eventually going to mature into a lymphocyte. Could be a B or a T lymphocyte. Myeloid stem cells are then going to be affected by multi-CSF. Now remember, multi-CSF nudges cells to become either a neutrophil, eosinophil, basophil, or platelet. So this cell is going to differentiate. And then if GM-CSF comes along, and that stands for granulocytes and monocytes, those cells are going to further differentiate. If GCSF comes along, it's going to nudge that cell into becoming one of the three types of granulocytes, basophil, eosinophil, or neutrophil. However, if instead MCSF is present, that will nudge this progenitor cell to become a monocyte. And then if the myeloid stem cell is in the presence of EPO, what do you think EPO stands for? And here's a hint, look down here. It's going to cause the cell to become an erythrocyte. Well, EPO stands for erythropoietin. Then that hormone is going to stimulate the cell to become an erythrocyte. So again, when you take a look at this, you can kind of see how the stem cell, which really is undifferentiated, gets nudged by different hormones, different cytokines in this case, to become a more specific cell. Now, a little bit of terminology here. Leukocytosis is a word that means an abnormally high number of white blood cells, usually an indication of some type of infection. Leukopenia means an abnormally low white blood cell count. And then leukemia means an extremely high white blood cell count with a low red blood cell count and a low platelet count. So these are some terms that you should become familiar with. Let's take a look at platelets now, the last type of formed elements. And platelets are actually pieces of large cells. They're pieces of cytoplasm that come from a large cell called a megakaryocyte. So what happens is if we are in, let's just assume here, this is the bone marrow. Okay, and we have the stem cell in here, we have stem cells, but then we have this cell called a megakaryocyte, which is a giant, mega means giant cell. It has multiple nuclei, and it's got lots of granules. Okay, now this is capillaries that are running by it, so I'm just going to write the bloodstream. And so the blood is traveling, flowing by. Now there are little openings in this capillary. And so what happens is the megakaryocyte squeezes and oozes itself out, kind of like that. See, it's kind of oozing out into the bloodstream, and we'll just put the little granules there. And then after a while, because of the blood flow, these pieces break off like that, and they float away. And so that's what the platelets are. They're pieces of this large megakaryocyte. They do have granules that stain purple, and the granules can consist of serotonin, calcium ion, enzymes, ADP, and something called platelet-derived growth factor. The purpose of platelets is to basically form a temporary plug in a damaged blood vessel. So when the tunics of a blood vessel are torn, the platelets will come together and plug it up. So they're involved in the clotting process, and there's a temporary, at least, loss of blood flow. Platelets circulate for about 9 to 12 days before they are removed by the spleen, and their production is stimulated by interleukin-6, multi-CSF, and something called thrombopoietin. Now, a little bit more terminology here. People that have an unusually low platelet count are said to have thrombocytopenia. Thrombocytopenia. So there's that term penia again that we saw with leukopenia, meaning low. In this case, it means low platelets. High platelets are said to be something called thrombocytosis. And again, we saw this suffix cytosis before with leukocytosis, which means too many platelets. And of course, that's dangerous. When you have thrombocytosis, you have increased viscosity of blood, which increases blood pressure, but also increases the chances for a clot or a stroke. Okay, so let's move on now and talk about hemostasis, which is bleeding. The mechanism used by the body to stop bleeding. It is a complex cascade in which one chemical stimulates the next one, and the next, and the next, and the next, and kind of happens in that way. There are 3 phases that happen in very quick sequence: platelet plug formation, vascular spasm, and coagulation or blood clotting. All of these interact to some degree with each other. Usually, platelet plug and vascular spasm happen first, and then coagulation happens last. So let's look at vascular spasm first. And whenever there is damage to the tunics, the 3 tunics, it causes the tunica intima to release endothelin. So you remember endothelins from the chapter on blood vessels. Endothelins cause vasoconstriction. Remember, these are intense vasoconstrictors. Okay, so again, whenever there is damage to the tunics, the tunica intima releases endothelins, and that causes the smooth muscle in the tunica media to contract, which partially closes the blood vessel. In addition, platelets that are already anchored release serotonin. Now, you remember serotonin from the nervous system. It's a neurotransmitter that's involved in mood. But here, serotonin causes the smooth muscle to contract. So here's another thing that causes the blood vessel to contract. There is another chemical called eicosanoids. And you remember eicosanoids from the endocrine system. So eicosanoids are actually hormones that are released from one cell and often travel to the next cell. So they don't travel a long distance. And one particular hormone, one particular eicosanoid is called prostaglandin. Prostaglandin also causes vascular spasm. So all of these things, endothelins, serotonin, prostaglandins, will narrow the blood vessel to decrease blood loss. And this decrease can actually prevent blood loss for about 20 to 30 minutes. Now, during that time, the platelet plug is forming and also coagulation is occurring. What about platelet plug formation? Well, this usually begins about 15 seconds after injury to the tunics. So if we look here, we can see the 3 tunics. This is the inside of the blood vessel. And then here the endothelium is actually the tunica intima. Here we have the middle layer of smooth muscle, the tunica media, and then here on the bottom we have connective tissue, which is the tunica externa. So you can see this blood vessel has been torn all the way through. Now, platelets are traveling in your blood, these little purple things, and they never stick. However, when the tunics are torn, if the tunica externa sticks out into the lumen, and the tunica externa has a lot of collagen in it, well, if the platelets come in contact with the collagen, they change and they become sticky and they will cling to those collagen fibers. Now, once some of the platelets attach, they release ADP. And ADP attracts more platelets. Once those platelets stick, they release ADP. That attracts more platelets. And pretty soon you have a plug in the opening made of platelets, platelet plug. Now I want to just go back to ADP for a minute because this is actually adenosine diphosphate. And you may remember this chemical. This is the one where if you add one more phosphate, you get ATP, which is an energy molecule, an energy molecule for the cell. But here, ADP is acting to actually attract more platelets. So that's kind of an interesting role. So now we have the vascular spasm and the platelet plug, which